More than 600 million kilometers from Earth, a small frozen world circles the largest planet in our solar system. Its surface is silent, cracked, and exposed to deadly radiation. But beneath the ice may exist an ocean unlike anything humanity has explored. Europa is one of Jupiter's 4 largest moons. It is slightly smaller than Earth's moon and has a young-looking surface covered with ridges, fractures, and reddish-brown streaks. This moon is constantly being stretched by the gravity of Jupiter and nearby moons. This gravitational flexing may generate heat inside Europa, helping keep water liquid beneath its frozen surface. Europa appears lifeless from above, but its fractured surface may be hiding one of the largest oceans in the solar system. Voyager and Galileo spacecraft approached the realm of Jupiter, carrying our curiosity into the deep dark. Voyager's cameras captured Europa's surface, a web of cracks across an unusually smooth world. Later, NASA's Galileo spacecraft made 12 close passes, detecting a curious induced magnetic field. Scientists believe the most likely explanation is a global ocean of salty liquid water, conducting electricity beneath the ice. Beneath the frozen crust lies a deep global ocean resting upon a rocky seafloor. This hidden world may contain more than twice as much liquid water as all Earth's oceans combined. We see hints of water vapor rising above these icy fractures, though the evidence for active plumes remains under investigation. We have never directly seen Europa's ocean, but its magnetic field, fractured surface, and internal structure all point toward the same extraordinary possibility: a vast body of liquid water hidden in darkness. In that darkness, we must wonder, what could exist inside it? What lies beneath the frozen shell of Europa? To find out, we must travel through the moon's fractured ice and descend into a dark alien ocean. Scientists do not yet know the exact thickness of this ice or the true depth of the water below, but beneath the waves there is likely a solid, rocky seafloor. This hidden world is not cold and dead. Europa's interior is constantly heated, as Jupiter's immense gravity repeatedly stretches and squeezes the moon. This tidal heating could drive vital chemical reactions or even fuel hydrothermal activity on the ocean floor. On Earth, we know that hydrothermal vents support entire ecosystems without a single ray of sunlight. Recent data from the James Webb Space Telescope has detected carbon dioxide on Europa's surface, which likely originated in its subsurface ocean. Carbon is essential for life as we know it, but while its presence is a major clue, it does not prove that life exists there. Europa may contain water, useful chemistry, and a continuing energy source, the 3 broad ingredients associated with habitability. But suitable conditions do not guarantee that anything is alive. If all the ingredients for life are there, is anyone home? The most important question is not whether Europa contains monsters or advanced civilizations. It is whether biology can begin independently in a dark ocean far from Earth. Welcome to a journey across the solar system, moving away from the warmth of our sun toward the mysterious frozen frontier of Jupiter's moon, Europa. Europa appears as a gleaming white marble, its surface scarred by deep reddish fractures, hiding a vast secret beneath its impenetrable shell of ice. We descend now, passing through the jagged crevasses of the outer crust, moving into a realm where the concept of day and night ceases to exist. Here in the subsurface ocean, the environment is pitch black. The only movement is the slow, haunting drift of marine snow through the freezing water. The physics of this world are defined by extreme isolation. Above us lies a massive ice crust, miles thick, creating a barrier no sunlight can penetrate. In these conditions, the fundamental engine of earthly life, photosynthesis, is impossible. There is no light to drive the growth of plants or algae. Yet, where light fails, chemistry might succeed. This leads us to the concept of chemosynthesis, life fueled by chemical reactions between water and rock. To understand if this is possible, we must look at earthly analogues. In the deepest parts of our own oceans, life thrives in the absence of the sun. Around these hydrothermal vents, microorganisms and complex creatures flourish in extreme heat and chemical richness, independent of the world above. We see life's tenacity in other extreme environments, like the subglacial lakes of Antarctica, buried under miles of ancient crushing ice. Even deep within the Earth's solid rock layers, specialized bacteria survive in conditions we once thought were sterile and uninhabitable. Could similar microscopic single-celled organisms be drifting in the dark currents of Europa? Scientists envision hardy microbes adapted to high pressure, but we must temper our hope with scientific skepticism. Europa's seafloor remains a mystery, potentially plagued by chemical hostility or extreme nutrient scarcity. Without significant geological activity, the ocean could be a sterile void, a vast expanse of water where the spark of life never caught hold. The uncertainty of geological activity means we do not yet know if the ingredients for biology are even present in sufficient quantities. Despite the challenges, the horizon of discovery is closer than ever. NASA's upcoming missions are designed to pierce this veil of ice and mystery. Equipped with advanced sensors and probes, these missions will search for chemical signatures and plumes erupting from the moon's hidden depths. We return now from the dark ocean voids, moving back through the frozen ceiling toward the light of a new era in exploration. If even microscopic life exists there, it would mean life began at least twice within one solar system. Welcome to the Infinite Archive. Here, the history of our species is written not just in books, but in the stars we reach for. A new chapter begins today. We turn our gaze toward a moon of ice, where the secrets of life may be waiting. NASA's Europa Clipper mission is a journey of discovery, a quest to explore the habitability of a world millions of miles away. On a clear morning at Kennedy Space Center, the Falcon Heavy stands ready, a monument to human ingenuity and our endless curiosity. Ignition. A thunderous roar shakes the ground as the most powerful operational rocket in the world lifts off toward the heavens. Trailing a pillar of flame, the Clipper ascends, leaving the blue marble of Earth behind for the deep silence of space. The journey to Jupiter is not a straight line, but a complex cosmic ballet spanning 2.9 billion kilometers across the void. Navigating through the gravitational tides of the solar system, the spacecraft gathers speed for its long-awaited encounter with the giant planet. For 6 long years, the Clipper will travel through the cold dark, guided by the precise calculations of engineers back on Earth. The destination: April 2030, a date that marks the beginning of a transformative era in planetary science and exploration. As the sun fades to a distant spark, the spacecraft unfurls its massive solar wings, stretching wider than a basketball court. These arrays are designed to capture the faint light of the outer solar system, powering the mission's advanced scientific sensors. Every component, from the propulsion system to the delicate cameras, has been engineered to withstand the brutal environment of deep space. Encased in a protective vault, the spacecraft's brains are shielded from the intense radiation that surrounds the gas giant Jupiter. Entering Jupiter's orbit is a high-stakes maneuver. The gravity of the massive planet will pull the Clipper into its powerful embrace. But the mission doesn't land on Europa. Instead, it orbits Jupiter, making tactical passes to study the icy moon from afar. The plan involves 49 dedicated flybys, each one a chance to peel back another layer of Europa's frozen, enigmatic surface. Diving as low as 25 kilometers above the ice, the Clipper will capture images and data with unprecedented clarity. Equipped with 9 primary instruments, the spacecraft is a mobile laboratory, designed to probe the moon's hidden internal structure. Ice-penetrating radar will pulse through the crust, searching for the interface between the frozen surface and the liquid ocean below. High-resolution cameras will map the chaos terrain, mysterious ridges and cracks that suggest the ice is active and moving. Thermal sensors will search for warm spots, potential signs of cryovolcanism, or plumes venting water vapor into the thin atmosphere. Spectrometers will analyze the chemical composition, looking for organic compounds and salts that are the building blocks of habitability. Beneath miles of solid ice, a vast ocean of liquid water is believed to exist, kept warm by the moon's tidal flexing. This hidden sea could contain more liquid water than all of Earth's oceans combined, creating a potential sanctuary for life. The mission's goal is not to find life itself, but to determine if the ingredients, water, energy, and chemistry, are present. If Europa has the right conditions, it could change everything we know about our place in the cosmic neighborhood. The mission is fraught with danger. Jupiter's magnetosphere acts as a particle accelerator, blasting the spacecraft with lethal radiation. But with every daring flyby, we move closer to understanding whether life can flourish in the dark, cold depths of space. The Europa Clipper is our messenger to the stars, seeking a future where we are no longer alone in the dark. As the spacecraft drifts toward the shadow of Jupiter, the search for habitability continues. The archive remains open.
Europa could change how humanity searches for life. A habitable environment does not necessarily require an Earth-like surface, warm sunlight, or a nearby star. If Europa's ocean has water, chemistry, and energy but remains lifeless, scientists must ask what additional ingredient life requires. If life exists there, even in microscopic form, it would be one of the greatest discoveries in human history. Europa's ocean has remained sealed beneath ice for perhaps billions of years. We do not know whether it is empty or whether something has been living there throughout human history. Europa Clipper will not give us every answer, but it may show us where to search next.